Here we have Recursion Day 4, and this is the notes. We got a method call here, fun2, and we're going to send x10. Now, if x is less than 1, nope, it's greater than 1. It's going to do the else. System out print x. All right, so print 10. And then it calls itself and sends x7. 7's not less than 1. It's going to print 7. Then reduces x by 3, calls itself, so it's going to send 4, prints 4. Reduces by 3, prints 1. And then finally, when it's negative 2, when we take 1 minus 3, we get negative 2. Finally, x will be less than 1. It does the escape sequence n, which is new line, and then prints done. All right, we're going to print out the return of comp 5. So n gets 5. If n is equal to 1, no. This is called the base case, by the way. Base case. Else return, all right, it's going to call itself. Let's get a stack going here where n equals 5, and it calls itself because n is not 1. It's going to do the else, and we're going to call comp n minus 1. N is going to be reduced by 1, and then it calls itself. And 1 is going to stop this when n is 1. So n equals 2, calls itself. Finally, n equals 1. Now, when n is 1, it returns 2 times 1, which is 2. So this is going to return a value of 2. Then we're going to finish out the program. So we're going to add 2. That returns 4. Add 2 returns 6. Add 2 returns 8, and then finally, from the very first call, adds 2. The final answer is 10. Let's write a recursive program that returns n factorial. So if we call factorial 5, it returns, I believe that's 120, because 5 times 4 times 3 times 2 times 1. 20 times 3 is 60 times 2, yep, 120. Let's bring that up. Here is the hello world. Let's change this to about factorial, and 5 should print out 120. So we'll go public. We'll make this static so we don't have to create an object. We're going to return an integer, factorial, and we need an integer n, let's say. Well, we can say if n is equal to 1, then we'll return 1. Else, we do factorial. Now we'll do n return n times factorial n minus 1. So we'll work all the way down. We'll go 5, 4, 3, 2, 1. Once 1 returns 1. If it's not, then we'll keep calling itself. So I think this should work. So this should say 120. There you go, 120 right there, 120. Got it. All right, the next little program, we have comp 5. So we're going to send this 5. If n equals 1 or n equals 2, return 2 times whatever n is at the time. Let's make a stack here where n is equal to 5. And it's calling itself, and it's sending n equals 4. Calling itself, n equals 3. Call itself, n equals 2. N equals 2, so it won't call itself. N equals 2. It's going to return back to here. It's going to return 4 because it's going to double. But now, this method right here has to finish. So plus, it calls itself, but it's going to reduce this by 2. So n equals 1. Well, if n equals 1, that's going to return 2 times 1. So it returns 2 here. Now we've finished the method. This goes to 6. It's going to finish the method by calling itself. but reduces 4 by 2. So now n is equal to 2. And if n is equal to 2, return 2 times 2, so returns 4. Now it finishes, returns 10, and we have to finish this one. So now n is going to be equal to, we're going to reduce 5 by 2, that's going to be 3. Calls itself, reduces by 1, n equals 2. N is 2, so 2 times 2, this becomes 4. Now it has to finish this second part right here. Plus. And then it reduces this by 2, so now n is equal to 1. If n is equal to 1, 2 times 1 is 2. This is 6 from here, 4 plus 2. And the final number it prints is 16. Here we have wow. We have one parameter, that's a string, it's computer, and an integer, which is 2. So this gets computer, and this gets the value 2. If position 2 is greater than the length, 1, 2, 3, 4, 5, 6, 7, 8. So this is 8 right now. That's false, so it'll do the else. Return S. So S is equal to computer. Here's our stack. And POS position is 2. Well, we decided that this was false right now, so it's going to return S, return computer, but plus, and it's going to call itself. Now, what is it sending to itself? It's sending the substring from position to the end. So from 2 to the end, it's going to be 0, 1, 2. So mputer. So now S is equal to mputer. And position is equal to 3. So 1, 2, 3, 4, 5, 6 is the length. So if position 3 is greater than length 6, that's false. It's going to return S. S is mputer plus, it's going to call itself now. And it sends S equal to position to the end, 0, 1, 2, 3 to the end. So T, E, and R, and position just became 4. Well, now the length is 3. So now if position 4 is greater than length 3, that's actually true. It's going to return the substring 0 to half the length. So the length is 3 divided by 2. So it's going to send 0 to 1. Now remember, when you go from 0 to 1, it'll include 0, but not include 1. So it just sends back, this is a plus, by the way, sends back T. So then this sends back mputer T. And so what is eventually printed is computer mputer T. Public class void main. All right, so we got array. We got an array of 1, 2, 3, 4, 4, 4. System out print wow. We're going to call wow. We're going to send the array. We're going to send an integer 0, and we're going to send a value of 4, and we're going to decide what is this actually doing. So if I, let's see, what is I? We got 0. This is the number 4, and of course we have the array. If 0 is greater than or equal to array length 1, 2, 3, 4, 5, 6. If it's greater than 6, return 0. No, if array I, so we're going to start with array 0 is equal to 4, return 1 plus wow. That's actually false. 0 is 1, it's not 4. We're going to return, all right, so for the first one, we're going to turn 0 plus, and it's going to call itself, and we're going to add 1 to I. So that's the only thing that changes. Array stays the same, X stays the same, so I gets 1. So if 1 is greater than or equal to 6, no, Is array of 1 equal to 4? No. So then it's going to do return 0 plus call itself, and I gets one more. So it's going to go 2, no, 2, 0, 1, 2, no, 0 plus this. All right, so now I think we're kind of in business here. Watch this. So I becomes 3, 0, 1, 2, 3. Is array of 3 equal to 4? Yes, it is. So now we have 1 plus calls itself. So I gets one more. So now it becomes 4. Is array of 4, 4? 0, 1, 2, 3, 4. Yep, it sure is. So this will be a 1 plus here. We're almost done. So now we go to 5. I gets 5. Is array of 5, 4? It is. So we have 1 plus call itself. And then finally, when we get 6, 6 is equal to 6. So it just returns 0. This 1 plus 0 is 1. 1 plus 1 is 2. 2 plus 1 is 3. 3, 3, and 3. And what it's counting, it's starting at 0. Starting at 0 in the array. Starting at position 0 and counting how many 4s are in the array. That's what this is trying to accomplish.